the part is right. So the title of the article is Ball Game to Incompleteness. Incompleteness, loosely speaking, means that we are going to arrive at statements which are true. What does something being true means? One can describe, but some statements which are true, but which cannot be proved. Okay, what does it mean to prove something? That's question mark. But cannot be proved. I'm saying this without defining what does proving something means and what does something being true. Both the things can be made concrete. Some logic and modern theory. But the first, let me also mention the authors. I think it should be mentioned. Arindama Singh. I think IIT Madras. Okay. So the game is very simple. It's a ball game. So, right. So what is the game? So we have a box. We have a box. And it contains some finitely many numbered balls. So this is the box B. B contains finitely many numbered balls. And don't correct me if there is something wrong here. Numbered balls. And then there is maybe, and you can with repetition, but they are finitely many. So this is one. Now, there's only one player involved. The game, I should say that player, but there's only one player involved. Okay? At each step, you take a ball from the box. Okay, you pick a ball, but you're not looking at the ball. Okay, it doesn't matter, but yeah, I just say that you're not looking at the ball, just picking a ball. So pick a ball and say that number on the picked ball is n. Okay, then you choose any number m, choose some m which is less than n. This less than is there for a reason because we want the game to end. You'll see. Choose m less than n and any L in n. Okay, L doesn't have any condition. It's just that it's a natural number. It cannot be infinite. And 4 is replace the, you understand, replace the picked ball by L copies of ball, L copies of ball, L copies. Yeah, exactly. L copies of ball labeled M. Correct. Ball labeled M. So we are decreasing the label of the ball, but the number of balls might increase. So yeah, so you play this game, and the main claim here is claim. Okay, and the game ends if the game ends if there are no balls in the ball. Game ends when the ball is there.
So what if we and so what is the numbering on these balls? Are they like from one to
No, any
some
number.
natural number or 2, 3?
So can I add one more thing?
Yes.
I think there's one more constraint. Like if the ball is numbered 1, like we are supposed to move it out. Like
Correct.
if the
Yeah.
ball, yeah,
Yeah, that is not said here.
Yeah, that was my doubt. Like, what
Okay.
happens when you pick the
One.
smallest numbered ball?
Right. Exactly. If you pick the number one, then you remove the ball because you cannot do anything. But if you pick the number two, then you can replace it with 100 copies of ball labeled one. Okay. So that is it. I should mention that. But so game ends when box is empty. Okay.
you're right. So basically, what he told was he thought about it as the consequence of the constraint, right? Like m less than n.
Hmm.
Okay, I see. I see.
Yeah, I think it's because no, it's because the rules were not complete, right? I mean,
Right,
I did
right,
not,
right. Yeah.
yeah, I didn't say anything for one. So this is the thing, and the claim is that the game ends,
So that
right?
L is fixed throughout the process, or do you keep changing it
No,
each time you?
it will depend on n. It will depend on n. It will
Okay,
depend on n.
okay.
So you can take it as large as you want, and so on, right? So the claim is that the game ends. What does it mean? So, for example, if you have the number two, okay, if you have the number two, then the game will obviously end, right? Because you replace it with certain copies of one, right?
Right.
And suppose you have the number three, then let's say you replace it with 100 copies of two, right? But then again, you see the game has to end, right?
Mm-hmm.
Yeah, Aryan is seeing that. If you replace it with 100 copies of two, then you can see that infinitely after some finitely many steps, the game has to end, right? So basically, I mean, once you, yeah,
Yes,
if you
yes, sir.
keep, right, if you keep making the choices, that the game will end. But the point here is that you can make the game go for as, I mean, yeah, so any
As long as they
particular,
want.
you're right, yeah, any particular run of the game will end, yeah. But you can always produce games of larger and larger runs. You cannot produce an infinite game, but you can produce games of larger and larger runs, means length, right? With the same starting configuration, you start with the same starting configuration 3. There is one run which you do replace it by 100 balls like this of number 2, and you play. It will end in some number of steps, but you could have replaced it with 1,000 twos, and again it will take larger number, right? So you understand, Aryan, is this clear that there's no contradiction, that yeah,
Yes.
you may not see the proof of this fact that the game ends, but there is no contradiction.
Intuitively, yeah,
Yes.
yeah.
So for the proof, we will refer you to the paper, and in the paper you will see we did prove it by our own sort of our
Yeah.
own way last time. But if you see the paper, they apply that fan theorem. Okay, so the tree is finite. They'll make some tree out of it and show that it is finite. But we won't go into that right now. Okay, that you should read it.
Mhm.
So this is an interesting. But how does it connect with incompleteness? That we should discuss. And so yeah, let's just keep these rules here. Now we will construct some things which are true, but we cannot prove them. And after we are done with this, then we'll see. So just for this being precise,
Do you mind telling what exactly does it mean to be incomplete? I am not sure if I'm sure with the
yeah.
term.
So yes, incompleteness is sort of something which is bad. Incompleteness is, in a way, it refers to something which initially evokes a bad sense. right?
Mm-hmm.
That is, we understand. So incompleteness in real analysis is there, right? Incompleteness, incomplete spaces which are not complete. Metric space if you have studied, otherwise, so when Cauchy sequence doesn't converge, Cauchy sequences converge in R. Maybe Aryan, I don't know if you have studied it, but Cauchy sequences will converge. Right? So that's a good thing. That's called completeness. And if that doesn't happen, then we say it's incomplete. So incompleteness is a bad thing, but in this case, incompleteness means that something is true, which
How
means
do
it's
we say that something is complete? Like what count to be complete?
right.
That's
So yeah. So in this case, I'll just say what incompleteness means. Incompleteness means
yeah.
that there is always a statement. Okay.
Mm-hmm.
There is always a statement which is true. Okay.
Okay.
True, I would say, uh, means that if you take any concrete model of the theory, then there you will see
Mm-hmm.
that it is holding. But you cannot write a proof for that, for the truth of the statement.
Okay.
Okay. And it is not such a bad thing, because I mean, why should we think that everything is provable? That is a belief, right?
Right.
That
Yeah.
things should be proven. Proof and logic is just one path to the truth. It doesn't
So,
necessarily.
but
Yeah.
how can we say that true if
Yes,
when
exactly.
we don't have?
Yeah,
Yeah.
because
You don't have proof.
because the definition of truth is not based on whether something can be proved or not. That is what, yeah, I understand that that is the usually that's what we call truth to be, right? That's what we come to assume, but that is not how it is defined, and that's not how it should be defined also. But let me not talk about how it should be, but it's not defined like that. Okay, something is
Right.
true means that, so you have given some statements, you have given some bunch of axioms. Okay, and then you are given some language. Okay, some language, and from that language there is some axioms. Okay, and then there is a statement whose sort of atomic parts come from that language. Okay? Now this statement, okay, is there. Now when you consider a model, which means that a structure, which means that there is a set and actual functions, okay, where you can impose this language, and where you can verify that these axioms are true. Okay, so you get a model, right? In that model you will see that this statement is true. Okay, and in any model you can construct, you will see that the statement is true. Okay, but proof means what? When you say proof should not refer to a particular model. In our case, we know that proof should not depend on the particular case. You see, right? Writing a proof means, right, that it should not refer to a particular case, that we should not refer to this particular configuration
Right.
of cards. We should show that for every
Exactly.
exactly, right?
Every configuration.
Exactly. So, well, truth basically means that there is an infinite length proof, but not
Mm-hmm.
having a proof when there is no finite length proof. Means there are infinitely many cases, and you somehow don't have a way of proving it without considering all the infinitely many cases. You can think of it like that. Yeah.
Yeah.
Aryan, is that slightly convincing a little bit? Right.
Yes. I mean, it's confusing, but I
Yeah.
think I think I'm getting what you're saying. I mean,
Uh,
I'm looking back to that construction that I think it's called Gödel numbering. So
yes.
Exactly.
I'm trying
Something
to
like that.
make an analogy with that.
Yes, that is precisely so. If you read, then you will see that that is another such. So basically, this article is for that purpose. It doesn't go to Gödel numbering sort of. If you really want to understand it, I think you will need a bit more background. So I'm not sure. Okay, if you want to like completely understand it rigorously, but this article is just to basically for students to understand that, yeah,
Get a feel.
something is true and not. Yeah, of course, after that, it's advisable to quickly move into a proper study of these things to really, you know, uh, uh,
Mm-hmm.
yeah. But yeah, anyway, so incompleteness, we will. So this is what we are going to discuss, right? So now let us look at this. Look at this sentence. So if you look at this sentence, PK, which is basically just parameterized by natural number. So K is natural number, and you're looking at this sentence. This is all from straight from the article. I'm just doing sort of a summary. Okay. PK is uh, that the game definitely ends in less than k steps. Okay.
Right.
So yeah, what should I say? Yeah, is it true?
Payments.
Is it true? So
So,
I
I
should
mean, doesn't it depend on the configuration? If I have a game that ends in one step, then yes, it's true for all
right,
naturals.
right. So I should say that you fix a configuration. No, not a configuration. I should say fix an initial configuration. Okay, fix an initial non-trivial non-trivial because if you just have ones, then yes, then it's not interesting. Non-trivial configuration, which means let's say it has at least 1 2. Okay, so you fix an initial non-trivial configuration. Okay, now when this is asked that pk definitely ends in less than or equal to k steps, this means that no matter how you play the game, no matter how you run, configuration is one, but after the initial configuration there are infinitely many ways to play the game,
Yeah.
right? So that we are considering. So when we say game definitely ends in less than k steps, it means that no matter how you play, it ends in less than k
There
steps,
is.
which is obviously
Oh,
not
there
true.
is some care.
Okay, correct? Yeah.
Yeah.
So this is obviously not true. So this is false.
Because, like you said, we can make it
Yeah,
arbitrarily big, the number of steps.
exactly. Yeah, but we have to go
Okay.
to different runs for the same game, for the
Yes.
same initial game. You have to go to different runs to get yeah, as you said. So this is false. But then if you look
So,
at the state,
so sorry, like, are we saying, like, let's say that the same thing, so the same argument, like, are we saying it is false because any K that you say we can prolong the game? Is that the reason why we are saying it's
yes,
false?
yes, exactly. Yeah. So false
But
for
yeah,
every k, for any given k, for any given k,
all
right?
right.
Yeah. So for
Okay.
any k, this statement is, so there are infinitely many statements there. Okay. Yeah, it is false.
Mm-hmm.
All of them are false. Now, if you look at this statement, and this is where the yeah, that there exists a k such that pk. This is true.
PK is true. Yes, it does. It has to end in some sense.
Yeah. So you starting with a configuration. Okay. Now you take a run. Then for that run there is a k such that pk is true. Right.
It's true.
You
Yeah.
take any other run. Again pk is for some other k, but there exists a k. Right.
Right. As long as the game run is fine. I mean, as long as we do whatever is given in the right, it will
Yes, of
it
course. If you
will end
don't
in
do
some
that,
way.
then it becomes something else. Right, exactly.
Yeah.
Okay. So, so the point is that yeah, this is all. I shouldn't say anything more. I suppose that this is true. Okay. So here we are seeing that like something is false there, and then here something it's strange, right? That for
Predicts.
every k it is false, but then
There
if
is some K which is true.
right. Let me just read it again if I'm just missing something. So yeah, this is paradoxical. We have proved that. Wait. Yeah. So there, then the ball game eventually ends is translated as there exists a k such that pk. Right. There exists a k such that pk, and we have
Even if,
proved. One second. Yeah,
yeah,
and we have proved that this statement is correct. Yeah. So it is not just it is true. I mean, we have proved that we have a proof, right?
So,
This is the
I
claim.
mean, shouldn't there be an extra condition on the true statement? Shouldn't it actually be there exists a run of the game such that it ends in there exists a K and a run of the game such that PK is true? Shouldn't that be the statement actually?
yeah, it is a statement, I guess, for the second one. There exists K P of K, which means there
Oh,
is some K which ends the game, right?
no. But what Aryan is asking is that there exists a case such that that no. So can you, Aryan? Can you say your question again?
So I don't see the paradox here actually. Like I
Okay, yeah. but you agree that this is one of them is that those statements are false and this statement is true.
Yes.
That's
Yes.
fine, right? Yeah, paradox. It will be more apparent because paradox is a strange thing, right? You may not see it, yeah, but you will see it next, I suppose. So, but all I'm saying is that this statement is proved because of this claim.
Right.
Okay. Yeah. Yes. Okay. Yeah, the paradox is more. I also did not see the paradox, but it becomes clear if we sort of take complements of these statements.
I'm sorry. Maybe I'm wrong, but then I am able to see the paradox. I don't know if it is because
Yeah.
like it is possible to find the K, like as we see it, the game will end. So there is some K that the game is ending. At the same time, I can that specific K can be prolonged. So it is paradoxical, right? Like let's say that the game ends in 10th step. That
Mm-hmm.
we in a run, I see that that game is ending in 10 in let's say like 10 steps. At
Mm-hmm.
the same time, I can prolong the game so that it won't end in case 10 steps.
Yes,
So,
but that one will end
but
in some
definitely for
other.
a different run.
No,
But
but
definitely
that
for
one
a
will
different
end in
run.
some other number of steps. So it is. I mean, I don't feel the paradox so far.
Yeah, okay, yeah.
That's yeah, because there exists because if you change the run,
Mm-hmm.
then the K
Right.
changes, but there is still a K which works.
Yes, sir. That's what
Anyway,
I was trying to say.
There is a different K, but then that K is no longer true, right?
yeah. So this not said that the same K should work for every run, right?
Yes, sir. That's what I was trying to say that K should be conditional on the like.
Uh,
It can change. It's not like one
yes,
K.
yes. No, but the K is conditional. This is there, right? Because if you take
Okay.
yeah, right. Because yeah, correct, right? Because if you take a game and then you take a run and then that run ends in there is a K for that run,
Right.
right? And then you change the run, then there is a K for that run also, right? Yeah. So this statement is true. So this statement is like you starting with a game and then for every run there is a K, right? For every run there is a K. Okay, right. Or
At the
you
same time,
can
I can also make at the same time I can also make that not end in K steps also, right? Like if you say that this game ends in that Kth step,
uh,
I have the choice of making not end in the K step, like but it's a different K.
correct. Yeah. So yeah, then right. So yeah, it comes down to interpretation. So if I'm changing the K, yeah, if you make it, but then some other K will work. That is
Some
all.
other K will work, but then it is again that K will itself. I don't know. It
Okay,
you
yeah.
cannot
So
specifically.
okay.
Yeah.
So let's and fix a run.
Mm-hmm.
Now can we say something? Let's see. So now we have given a configuration and we are given a run, right? So for
Okay.
that uh, given run,
There is a K.
there is a case such that mm, yeah. So can we say that these statements are uh, yeah? So what
I
does it
don't
mean?
think this will apply for a specific run. That the given statement in the above is not for a specific run. Like it has to, it I don't know. Like
Yeah.
it varies with
Yes,
the
sir.
run.
That's
Like
what I was thinking. So suppose this run is one that ends in 10 steps. Then this
Mm.
P of K will be true for all naturals greater than or equal to 10. It is not. So
Yes.
I think the first statement is a general statement, while the second statement is specific to each run. So that's why I don't see the paradox.
Yes, yes. Paradox is I also don't see it till now. Okay. But we are just
Okay.
trying to understand if our conclusion, because let's not talk about paradox. If that's a subjective thing. Okay. let's say.
Right.
So, but if you have understood the statements correctly, so let me see. So when you say that for a given, so if we fix a run, so I fixed a run for a certain reason. If we fix a run, then can we say that PK is true? So when you say PK and when you say PK is a statement of K,
Yeah, if we
right?
fix a run, definitely PK is true, right? Like if we fix a run, there is a K which the game ends. Say the 10th step the game ends. So definitely game ends in less than or equal to 10 steps. Like so no long
Yes,
I
correct.
cannot say that
Yeah, if
first
you have fixed a
makes sense.
run, then we cannot say correct. So maybe we should
Right.
not fix a run.
So
Right.
as long as we can both as long as we can as long as we have the choice of runs as well as the we can move the runs. I mean, as long as we have the control of the runs, I think both will contradict, I guess. Like
1 minute. Yeah. So
right,
first one. So we are not fixing the run. So this is the
right.
first one. And yeah, now wait.
Because the game actually is arbitrary,
Wait,
right?
wait,
Like
wait,
it
wait,
doesn't
wait,
make
wait, wait,
sense
wait,
to.
wait.
Right, sorry, sorry.
So 1 second. So what I think I figured it. Figure it. So see, when you are going to check the truth of any of those statements, you have to check it for
Mhm.
every run,
Right, yeah,
right? So run is not fixed. But when you check the truth,
right,
you check it for every run. So first one is clear. So when you check the second one, then you have to bring a game and bring a run. So when you bring a game and a run, then the statement is
right,
true. There is no problem,
right,
right?
yeah.
That's it.
Yes, yes, sir.
The
Yeah,
K will change, but that is not our matter, right? K is natural. That's all. So that's it. That's not a problem. Yeah.
yes.
But yeah,
So
now
the first statement is false for any given k because there always exists at least one game that needs k plus one
yeah,
steps or
at least
more.
one run. Yeah,
Yeah, and second one is true because every
yeah.
game ends.
That's a claim, right? Correct,
Yes.
correct. So that's the explanation. But then, if we look at this statement, K to QK, and QK is that the game. Right. So QK is the game does not end in K or fewer moves. So it's a complement of that. Okay. So game does not end in K or this is true.
So when we say it is true, we have to consider all the runs, right? It is not for a specific run that we are trying to come up with, right?
Yes, yes, yes. Correct. I mean, yeah. So basically, you can go by contradiction, and that is because the first one is false, and that's why this is true,
Mm-hmm.
right? Because the first it's a complement of the first statement, right? So yeah.
Yeah,
So this one is, I mean, of this one, it's a complement of this statement, so it is true. Means, yeah, one can write an explanation, but you understand. So this is true,
yeah.
and okay. Can we also say that we have proved it? Can we also say that we have proved it? Right? Yes, because we have proved that one to be false, right? And that's why we have proved this one to
Yeah, same reasoning. So there's always a game that ends in greater than k moves.
be. Yes, right. Because if this was false, if this was false, then it would mean that yeah, it's trivial, so it's fine. Yeah. Now,
The
if you
game
look,
that we produce, the game that we produce is actually a different run, right? Like I'm just making sure I get it. The
uh-huh,
game that we produce is a different run, right?
the game
Like
that we
produce is a different run.
the game that we produce is a different run.
Like we
What
said,
does that?
we we just said like the game does not end in K or fewer step. Like we said we can produce a different K. If we can
Ha.
produce a different K, that means that that K corresponds to a different run, right? Like it uh
Uh,
I'm sure if I
Okay,
made clear.
it is the complement of that statement, and that is false, so this is true.
Right. Yeah, if
So
that
that
is
way,
false, then it has to be
this
true,
is
right?
true.
But then,
Right. If
yeah.
you want to see it more directly, yeah. So suppose this is false, okay? Suppose this is false, then the game does end in k or fewer moves, right? Which means that
Mhm.
for every run, it should end in k or fewer moves, right? Because you're making the
Right.
statement for the game, but the game doesn't end in k or fewer moves for every run. So because you can produce, so for every k, you can produce a run, and that run will depend on k. I think that is what you were saying,
Yeah.
kind of, right? I think, yeah.
Yes.
Okay.
Yes, sir.
So yeah. Yes, I mean, I'm also doing these things after a very long time. So yeah, it's getting, but it's nice to do this, right? Yeah. This statement for all k,
Sure.
q, k. What can we say about this statement? You see, if k is true for, if this is true for every, right, it means that this is true. Correct?
Mhm.
It is true because these statements are true.
For all k, q of k, right? That's what
Ah,
you're.
yeah, sorry. That's why there's a silence. Yeah, sorry. Yeah. For all k, q, k. This is true because because that's what's written here, right? It's true for every k.
Mhm.
So this is true, but we cannot prove it to be true. Why?
Is it
Because this is the
infinite?
complement.
Um,
That is his yeah, but it's because that is there, but one can still prove it to be true, but you cannot prove it to be true because we have proved it to be false.
oh,
Because this is a
right. Yeah.
complement of this statement.
Uh-huh.
So it is proved to be false,
I cannot be. Yeah. Right.
but it is true. So we cannot prove it to be true, but it is true.
Right. Makes sense. Yeah.
Right, and the intuition sort of, I mean, he gives is that because it is true, but we cannot prove it to be true because it will need an infinite proof, because you sort of have to write a proof for every k.
Or we can just see less as you just showed. Like, it is the
Yes, I mean, that is a
yeah.
proof that it cannot be proved to be true, but the intuition is this, that is what the author writes.
I get it. Yeah. It is a
Yeah,
negation, so it cannot be true.
right, yeah, it cannot be proved to be true, but it is true because it is because for each k, because this is true, like
Yeah,
because
it falls
qk is
directly
true
from that
from the
above
above,
assumption.
right,
Yeah.
but because there are infinitely many statements, and because it cannot be condensed into a finite proof, it cannot be proved, and that's intuition that it cannot be proved, but the proof that it cannot be proved is following from this, because this can be proved to be true. Aryan, is it fine?
Yes, sir. I
So
sort of get it.
it's sort, yeah. So I'll send you the paper, and you should read this
Yes.
paper, and then you will have a better idea.
Yes, sir.
Okay. So right now, on this topic, I don't know if you should read something or not, but maybe if you are interested, let me look at the name of the book. I
It would be great, like if I can connect this with arithmetic, like how exactly the statements are related to statements about
yeah.
numbers.
So the problem is that to connect it, first you have to read some language, right? Yeah.
Right.
So introduction to this is easy to read, so you can read this book, and this we can keep in some discussion sessions. Obviously, this will not be part of the sort of,
Yeah.
this will not be but we can do this once a week, but we should see if you want to read this. Because I'm
Yeah.
telling you, because this is very easy to read. An introduction to Gödel's, yeah, theorem. Yeah, there are I mean, yeah, with arithmetic, but first some language has to be understood clearly, then otherwise you see the
Makes sense.
discussion will become very, yeah, and
Right.
that's why we need maths to discuss philosophy more objectively, kind of. So
Mm-hmm.
Peter Smith, okay, you can check this book. Any book is fine, but because I know of this book, I'm telling you. Yeah, so this you can think, it's up to you if you want to read this.
Right.
Okay.
Yep.
Yeah, and so what is the suggestion about the college stuff? right? So maybe we can discuss something on that. So I want to take a class on this. Will be some, we should do some college stuff. Okay. Maybe Tuesday, and we'll plan. Otherwise, it will become hodgepodge. So we should plan what to do. Tuesday, 8:30 p.m. Is this, first of all, is this time okay with both of you?
Yes, yes, it's fine with me, sir.
Fine
It's
with me.
fine.
Like,
Okay.
yeah.
Okay. So let me tell you what you should study, because otherwise, because we want to study in a way that we can track our progress. Then we can build confidence. We can track the progress. Otherwise, with college stuff, this now mathematics becomes very. It can become like a jungle. So careful in arranging what to study. So I will suggest you what to study. To read it. Okay, so what I want, this is very easy, is that you guys should completely read this chapter 1. You will know more than half of it, I suppose. Okay. Okay, but you should sit down and completely read this chapter 1. It's absolutely necessary to talk anything about higher math. Okay, kind of.
Yes, and this is R10, right?
R10, yes, I did
Yes.
say that.
Okay.
Yeah, R10. I have the second edition. That is not important, but yeah. So you should read this, and optional is if you can do the exercises. That I am not saying it's mandatory, but it's optional. Okay? But chapter you have to read completely, because it's all easy stuff, and you should read it. And of course, there might be things which you don't understand. Then we will discuss it. Okay? Because see, once you can understand it, to solve this, if you will take you a long way. Okay? Later on. Yeah. Okay, so we will build on this that day.
Art in algebra.
Art and algebra. Okay, one should read this. There is today is Sunday, so you should not take more than 4 hours, I suppose. Okay, if you actively read it. If you try to see through the repetitions, there will be a lot of repetitions. A lot of statements will follow from the other, but you have to see through all that jungle, and you have to pick out what is really the key. Okay, it's not in the sense of seeking shortcuts, but in the sense of what is really the germ of the seed. Okay, in that sense, you have to figure it out. Okay? So yeah, right, and then you will see it's not difficult. Yeah, obviously, I am not saying that you will be able to complete the chapter, but you should give your best. Okay, maybe tomorrow you can sit for some hours, and Tuesday you can sit for some hours. Okay, then we'll meet on Tuesday 8:30, and then we will see what to go. But we will do this in a very streamlined way, so that
Yes.
yeah, yeah. And then when we dedicate some,
I guess the next class after that will be analysis. Then
yes, maybe one class on problem solving, and then again we will see.
Okay, yes.
But we will do everything, but systematically. Okay, then
Yes,
yeah. Okay, then see you on Tuesday 8:30 p.m. Bye.
Yes, sir.